Ms. Humbert here, and today we're going to be doing our Unit 4 and 5 review. So it's going to be over factoring as well as some stuff about quadratics. So let's start by taking a look at number 1. So we want to simplify or solve quadratics using factoring and the zero product property. So first of all, what we want to do for number 1 is that's simply going to be a greatest common factor problem. So I want to figure out, okay, what can I divide 4 and 16 by? And that's going to be 4. And then I need to figure out what can I divide x squared and x by, and that's going to be x. And then I need to figure out what I can divide y and y by, and that's going to be y. So what I'm doing here is I'm dividing each of these terms by 4xy. Well, 4 divided by 4 is just 1. X squared over x is just going to be x, and then y over y cancels out. Negative 16 divided by 4 is 4, and then x over x cancels out to 1, and y over y cancels out to 1, so I don't need to write that. So this right here is your fully factored form. Nothing more can be factored. So let's take a look at number 2. So before I even try to start setting up the x, I notice that each of my terms is divisible by 3. So what I'm going to do is take out a greatest common factor of 3. So then I'm going to divide each of those by 3. Well, 3 divided by 3 is just 1, so I'm just going to write that as x squared. Negative 6 divided by 3 is negative 2, and then x. And 12 divided by 3 is 4. So we could take a look and we could try setting up the x. Well, we're multiplying to 4 and adding to negative 2. Well, that's not going to happen. So actually, this greatest common factor is the greatest factoring that we can do. So taking a look at number 3, so we can't take out a greatest common factor because we can't take a 3 out of that term right there. So what I need to do is multiply the first and the last terms. 3 times negative 12 is negative 36, and then we're adding to negative 1. So since we have a negative product, we're going to have positive and negative factors. So we need to figure out something that multiplies to 36 and adds to negative 1. And I actually can't think of anything. So I write NF, or not factorable. So this is not factorable. And there's no GCF we could take out either. So there's really nothing that can be done at all to simplify number 3. So taking a look at number 4, there's a 1 outside of here. So we're going to take 1 times a negative 18. And that's going to be a negative 18, and then we're adding to negative 3. So I can actually do that using negative 6 and positive 3. Remember, whenever you have a negative product, you need to have a negative factor and a positive factor. So I notice that my coefficient with the squared term is 1. So then we have x minus 6 and x plus 3. So I can immediately put it into factored form when my first coefficient is a 1. So that's my final answer for number 4. Next, let's take a look at number 5. So this one is going to use a method called differences of squares. So I notice I have a perfect square here, a perfect square here, and then a minus in the middle. So that means I can set it up to use differences of squares. So I set up 2 parentheses, put a plus in one, and a minus in the other. Then I'm going to do the square root of the first term in the first spot and write that out, and the square root of the second term in the second spot. Whoa! And then that gives me, whoa, this is going really well, and that's going to give me 5. Okay, now if you'll notice, that expression was set equal to 0, which makes it an equation. So we have this right here, and this is where the zero product property comes in. So the zero product property says that if those two factors are being multiplied, then each of those factors is going to equal 0 when we're solving this for x. So here when you subtract 5 from both sides, you get x is equal to a negative 5. Here when you add 5 to both sides, you get that x is equal to 5. So those are your 2 answers for number 5. Taking a look at number 6, we're multiplying to negative 15 and adding to negative 2. So that's going to be negative 5 and positive 3. Again, there's a 1 on the outside, so I can immediately put it into factored form. And that's going to be equal to 0. So x minus 5 is equal to 0, and x plus 3 is equal to 0. I'm taking and I'm writing each of those factors out separately using that zero product property idea. So x minus 5 is equal to 0. When you add 5 to both sides, you get that x is equal to 5. When you subtract 3 from both sides, you get that x is equal to negative 3. So that right there is your final answer for number 6. Let's take a look at number 7. So for number 7, we do have a number outside of the x squared term. So we're doing 4 times negative 6, which is negative 24, and that's adding to negative 5. So I'm going to end up using negative 8 and positive 3. Now the number outside of the squared term is not 1, so I need to break that up. So instead of having negative 5x, I need to do negative 8x plus 3x minus 6 is equal to 0. Okay? So now, all I did was I split up the negative 5x with the numbers that I found in the x. And now I'm ready to factor by grouping. So between 4 and 8, I get 4 and then x, and so I'm dividing each of those terms by 4x. Okay, so 4 divided by 4 is 1, so I don't actually have to write the 1. X squared divided by x is just x. Negative 8 divided by 4 is negative 2, and x over x will cancel to 1. Out of the second group, I can take out a 3, so when I divide each of those terms, I'm left with x minus 2. So here, I can factor out the x minus 2's, and I'm going to write those out. And once I've gotten rid of those, I'm going to write 4x plus 3. Now recall that that was set equal to 0. So what I need to do now is I need to take and set each of those factors equal to 0. X minus 2 is equal to 0, and 4x plus 3 is equal to 0. So here we get that x is equal to 2 when you solve that equation. And then the next one's going to take just a couple of extra steps. So you're going to start by subtracting 3 from both sides. So you get 4x is equal to negative 3. And then what we want to do when we have 4x is equal to negative 3, we're going to divide both sides by 4, and I get that x is equal to a negative 3 over 4. So then we have x is equal to 2 and x is equal to negative 3/4. So taking a look at number 8, so what could we divide 9 and 36 by? Well, we could divide 9 and 36 by 9. So when you divide both of those by 9, you end up getting x squared minus 4 is equal to 0. Now, I've always talked about the little sister, the greatest common factors being the little sister. Well, when it's set equal to 0, we can actually divide that 9 away, and it gets eaten by the 0. So all we have left is x squared minus 4 is equal to 0. Now, just so you're aware, if you forgot to take the greatest common factor out at the beginning, the answer will still work out. So this one, we can use differences of squares. So square root of the first term is x. Square root of the second term is 2. And that's equal to 0. So x plus 2 is equal to 0, and x minus 2 is equal to 0. So then you go ahead and you solve each of those equations for x, and you end up getting that x is 2 or negative 2 when you solve each of those equations. So let's go ahead and let's review that quadratic formula. So remember that the quadratic formula is x is equal to opposite of b plus or minus the square root of b squared minus 4 times a times c, and then all of that over 2 times a. Now remember, the quadratic formula is a lot about plugging it into your calculator correctly. So please make sure you are keeping track of your negatives. And just as a reminder, quadratics take the form ax squared plus bx plus c. So a always is with the square term, b is always with the x term, and c is always the constant. So let's take a look at number 9. So for number 9, we're going to solve this using the quadratic formula. So x is equal to opposite of b plus or minus the square root of b squared. Now notice I put that negative number in parentheses. Minus 4 times a times c, which is a negative 20. All of that over 2 times a. So what we're going to do in our calculator to start off with is we're going to take negative 7 and square it, minus 4 times 3 times negative 2. You can punch that all in your calculator at once, and using the parentheses helps to make sure you're doing it correctly. And then you end up getting 289, and that's divided by 2 times 3, which is 6. Well, I just happen to know that the square root of 289 is 17. So what I get is 7 plus or minus 17 divided by 6. So now I'm going to split that up. So I get 7 plus 17. So I'm going to type that in my calculator, 7 plus 17. Hit enter and then divide it by 6. And I end up getting 4. And then I do 7 minus 17 in my calculator. Again, hit enter, see what that answer is, and then divide it by 6. And I get a negative 1.67. So each of these right here are your final answers for number 9. Let's take a look at number 10. Now, in order to use the quadratic formula, it has to be set equal to 0. So we need to subtract 25 from both sides. So I end up getting x squared minus 2x minus 25 is equal to 0. And now we are ready to use that quadratic formula. So to use the quadratic formula, what we need to do is start by plugging it in. So we're going to have x is equal to the opposite of b plus or minus the square root of b squared, again in parentheses, minus 4 times a times c, all of that over 2 times a. And I'll give my computer a second to catch up to me here. So now we're going to simplify just what's underneath the radical first. So in my calculator, I do, with all the parentheses, negative 2 squared minus 4 times negative 2 times 1, sorry, that should be a 1, not a negative 2, because that's your a, times negative 25. And what you end up getting is 54. And you're taking that and dividing it by 2. So now the square root of 54 is not a perfect square. So here's what I do in my calculator. I do 2 plus the square root of 54. And then I hit enter. And I take that and I divide it by 2. And when I do that, I get 4.67. Please be cautious of your rounding. If the third number is 5 or greater, you need to round up. So then to minus the square root of 54, hit enter, get what the top is, then take your answer and divide it by 2. And I get negative 2.67. So each of these are your final answer for the quadratic formula. Last but not least, let's take a look at number 11. A projectile is shot vertically up in the air from ground level. Its distance s in feet after t seconds is given by that a quadratic there. We want to find the values of t when s is 96 feet. So that means we need to plug in 96 for s. So I get 96 is equal to 96t minus 16t squared. So again, to use the quadratic formula, you have to have it set equal to 0. So we're going to go ahead and subtract 96 from both sides. So then you get 0 is equal to, then our first term is negative 16t squared plus 96t minus 96. Okay, so if you notice what I did is I put it in standard form. I put my squared term first, then my t term, then my constant. So then we're going to do t is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c. And all of that is over 2 times a. Thank you. I have a lot for you again. So now what we need to do is simplify underneath the radical. So we can simplify this part out to start off with. So we have negative 96, and that's going to be plus or minus the square root. 96 squared minus 4 times negative 16 times negative 96 is going to be 3072. And that's going to be divided by negative 32. So now we need to split it up into plus and minus. So we have negative 96 plus the square root of 3072, and then we're going to take that and divide it by negative 32. Again, do negative 96 plus 3072, and then hit enter, and then do the negative divide by negative 32, and you get 1.26. And your label for that is going to be seconds, because we're talking about time. Then negative 96 minus the square root of 3072, hit enter, and then divide that by negative 32. And you end up getting 4.73, and again, your label is seconds. So that right there, both of these are times that it's going to hit 96 feet. And that concludes your note video for today. There is no Schoology quiz. Thanks for listening.